Principles of Technology, Unit 10, Energy Converters, Part 3, Fluid Systems.
We are completely surrounded by fluid energy. Motion of the wind and the water are free sources of energy provided by nature. Fluid energy converters, like a sailboat, convert the kinetic energy of the wind into the mechanical kinetic energy of the boat moving through the water. But that's only one kind of conversion. Fluid energy can also be turned into thermal or electrical energy. But all fluid energy converters have fluid energy on the input side. So a windmill converts fluid energy of the wind into mechanical, then electrical energy. We just said you can convert fluid energy into thermal energy, but unfortunately, we can't think of a device that does that. Can you? Although hydraulic systems like the one in this backhoe produce heat, it's a waste product of the process, and it's not useful. Most fluid energy converters are blades or vanes of some type that are spun by moving fluids. On this sailboat, John Hedgepeth used several energy converters to provide electricity during a voyage to Hawaii.
We were able to charge up the batteries to run the radio and the lights by several different methods. The first method that you'll see is the wind generator. And the wind generator is hooked up to the battery via this wire. And we can see that it's charging up about at a little less than 15 volts right now.
The generator part of the wind generator is also used in a different way. The windmill is taken off, and the generator is then fixed to the stern of the boat. A propeller on the end of a long line is attached, and the line is thrown overboard. The motion of the boat through the water spins the prop, twisting the line, and it turns the generator. The fluid energy of the wind becomes mechanical kinetic energy of the boat, then electrical energy from the generator.
That was very effective. In fact, we had to pull it out of the water quite a bit because we'd charge up the batteries. We kept an eye on a voltage meter similar to this that's mounted down below. And when the voltage of the batteries got up to 14 volts, we'd pull the outboard prop out of the water.
Another way of charging the batteries is a bank of solar cells, which convert sunlight directly into electricity. The solar cells can operate the radio and lights for a short period, but were mainly used as a trickle charger for the batteries. The solar cells do not produce as much energy as the wind generator. Keeping batteries charged on a long ocean voyage is usually done by running the ship's engines, but that consumes fuel, even on a sailboat. So how much fuel have these energy converters saved John Hedgepeth?
It seems like the people I talk to use their engines for 2 hours a day. Trips take about 20 to 30 days. So we're talking about running the engine for a minimum of 40 hours, 40 or 60 hours. And if you're burning gasoline, you're talking about maybe 60 to 100 gallons of gas. If you're burning diesel, it's a little bit less, but we were able to save that much in fuel.
The amount of energy saved depends on the efficiency of the energy conversion. That means that both the input and the output energy have to be measured. In fluid systems, the input energy is the kinetic energy of the fluid, which could be measured in joules. On the output side, the units depend on the form of energy, either foot-pounds or joules if it's mechanical, joules if it's electrical energy, and BTUs or calories if it's thermal. Here's another case where the units are different. But by simple conversion, the input and the output energies can be turned into the same units to find efficiency. The spinning blades of fluid energy converters sometimes handle a lot of energy, harnessing the wind, the water, or in the case of a jet engine, the blast of the hot gases escaping from the combustion chamber. Don Alderette of Garrett Airline Service Division is a technician who deals with that energy conversion inside a jet engine.
This is a gas turbine engine. Gas turbine engines are nothing more than energy converters. All gas turbine engines are air breathers. This gas turbine engine in particular is composed of a rotating group and a combustor can. The combustor can is very similar in operation to the cylinders in your own gasoline-driven engines. The operation of a gas turbine engine is very similar to an inflated toy balloon. If you take an inflated toy balloon and release the pressure through an opening, that balloon will be propelled in the direction opposite the opening. And as long as the pressure inside the toy balloon remains higher than the outside pressure, the balloon will keep on propelling itself in the same direction. The gas turbine engine is very similar to that. But in this case, we use the rotating group to draw in the air. The compressor wheel has but one primary function, and that's to draw in the fluid or the air and direct it under high pressure to the same combustor can we talked about before. At the appropriate time, we're going to introduce a spark and a source of fuel. It will burn due to the spark, resulting in an expansion of the gases. The gases, in turn, will be directed towards a set of turbine wheels, which will then convert that kinetic energy, that pneumatic energy, into mechanical energy, which in turn will drive the compressor wheel. The compressor wheel, in turn, will draw in more air. More air, more fuel, more expansion of gases, again directing the gases towards the turbine wheel, and the cycle repeats itself. On jet engines, utilizing the same gas turbine principles, the resultant gases escaping through the turbine wheels will propel the engine forward, and when installed on the aircraft, will propel the aircraft forward also.
Fluid energy converters convert the kinetic energy of moving fluids into some other form of energy. Usually that form is the rotational kinetic energy or torque of a rotating shaft. Fluid energy converters are popular because something like moving air can be used to drill your teeth. Moving waste gases can operate a turbocharger. Moving water can be converted into electricity. Moving hydraulic fluids can wash your car. And the kinetic energy of burning gases can carry us higher and farther than we've ever gone before.